Hi everyone, my name is Lin, and I'm gonna do the question 3 of the homework 1 recorded. So let's begin. First we can try to figure out what events we have for this question. So it says that digital 01, digital 1 or digital 0 is transmitted, and digital 1, digital 0 will be received. So we can have 4 events for this question. So let's suppose the event T1, which means the digital 1 is transmitted. And we will have event T0, which means digital 0 is transmitted. And we will have events for receiving. We will have event R0, and we will refer to the digital 0 is received. And we will have event R1, which means digital 1 is received. Then we will find out what the problem tells us, that the probability of these 4 events. It says that the transmitter sends out digital 0 with probability 0.6. So apparently we can have the probability of the event T0 is 0.6. And the transmitter will send out the digital 1 with probability 0.4. So apparently it's PT1 equals to 0.4. And then it says that when digital 0 is transmitted, so it's under the condition T0, the receiver receives digital 0, so it's the event R0. So the probability of it, it says is probability 0.7, so it equals to 0.7. And when 0 is transmitted, the receiver receives digital 1 with probability 0.3, so it's PR1, and under the condition T0, it will be equal to 0.3. And when digital 1 is transmitted, so it's under the condition T1, the receiver receives digital 0, the event R0. The probability of it is equal to probability 0.2. And finally, we have a PR1, and under condition T1, it has a probability of 0.8. So that's all the probability we have got for this question, and then we can find the solution of the 2 sub-questions. So the first sub-questions, it tells us to find the probability that data 0 is received. So it actually asks us to solve the PR0. So here we will use the total probability theorem, because we can find out that actually T1 and T0 is a portion of the whole space S, because apparently it's either digital 1 is transmitted or digital 0 is transmitted, so they are mutually exclusive, and the sum of their probabilities 0.6 plus 0.4, it equals to 1, so actually it's a portion of the S. So we will use the whole probability theorem here. So first, we will consider the under the circumstances that digital 0 is transmitted, so we will have PT0 here, and we will have PR0 under the conditional PT0. So it's actually times that, and we will plus that the event PT1 refers to the digital 1 is transmitted, and the condition probability for the T1 is PR and the condition T1. So then we'll only have to submit the actual number to it. P r in t under condition t0 is equal to 0.7 times pt0 is 0.6 and plus p r in under condition t1 is 0.2. It will times to pt1 0.4. So it will be equal to 0.42 and 0.08. So the answer will be 0.5. So that's the result of the first subproblem. So for the second subproblem, it actually has already given us some clues. It says that there are two situations. First, the two situations of the event arrow. It tells us to find the probability of arrow, which will equals to the probability that digital 1 is received when digital 0 is transmitted, and plus the digital 0 is received when digital 1 is transmitted. So let's consider the first condition. When digital 0 is transmitted, then it will just be pt0. So if 0 was transmitted, then the error will happen when digital 1 is received. So we will have to consider the p r1 under the circumstances t0 times. And then the second case is that when digital 1 was transmitted, so it will be pt1, and we will have to times it to the condition probability p r0 and the condition t1. So that's what the sum of it will be equals to p arrow. So again, we'll have to substitute the actual number into it. P r e t0 will be equals to 0.3 times 0.6 and plus p 0.2 times 0 times 4. Yes. Okay, so it's equals to 0.18 plus 0.06, 0.26. So that's the result of the second subproblem. So that's all for the question 3 of the homework 1. Thank you for watching.